Okay, number 7 is one that's worth taking a special look at because a lot of problems exist like this, where you have one triangle either overlapping or completely inside another triangle. This one's completely inside the other triangle, and in this kind of situation, it's a good idea to pull the one inside out so that you have two completely separate triangles. So I'm going to draw two completely separate triangles, one bigger than the other. The small one is A, B, E. And the bigger one is A, C, D. Now the reason that it's such a good idea to do this is because it helps me think about what these side lengths actually are. Because 3 is not a side length. It is just a little piece of a side length. From A to B is 9. And from A to C is actually 9 plus 3, so it's 12. So you have to take the time to think about this whole side being 9 plus 3, so that's how I get the 12 there. Now from B to E is 5, and from C to D is just X right now. So the first thing I was supposed to do on this one was explain why ABE is similar to ACD. We haven't talked about it a whole lot on this review, but remember there are 3 ways to tell if I have similar triangles. SAS, side angle side, side side side, and angle angle. Those are the 3 ways right here to know that you have similar triangles. So I'm trying to figure out which of those 3 ways applies to this situation. Well, I know that angle C is a right angle and so is angle B. So that counts as a pair of angles that I know is congruent because they're both 90 degrees, so they both have to be congruent. The other thing I know, and it helps again to have the triangles pulled apart like this, is that these are the same angle. If you look, we're talking about the same angle in the picture. We're talking about angle A. So this and this are not only congruent, they're exactly the same angle. So I have one angle pair that's congruent, 2 angle pairs that's congruent. That's angle angle. So that's how I know by angle angle that triangle ABE is similar to triangle ACD. And it says then find CD. So now that I know they're similar for sure, I can set up a proportion with my ratios of side lengths and solve it. So I'm going to say 9 over 12 should be the same as 5 over x because these are similar. So 9 over 12 equals 5 over x. That's a proportion. Anytime you have fraction equals fraction, that's what a proportion is. So now I'm going to cross multiply to solve my proportion. So I'm going to do 9 times x, and that gives me 9x. A lot of times people don't seem to know what to do with cross multiplying. When you cross multiply, you do your cross product. This is called a cross product, 9 times x. And that goes on one side, and then you have an equal sign in the middle. And then on the other side, you have 12 times 5. 12 times 5 being 60. So 9x equals 60. I'm running out of space, so I'm going to come up here. If 9x equals 60, I can divide both sides by 9. And let's see, 9 times 6 is 54. So it goes 6 times with 6 left over out of 9. So it's 6 2/3, or 6.6 repeating forever. Okay, I would probably do 6 2/3. Or you know what, another thing you can do, I could also just say, let's simplify this and leave it as an improper fraction. 3 goes into 60 20 times and into 9 3 times, and so I could say x equals 20 over 3. But I accept 20 over 3, or 6 2/3, or 6.6 repeating.